in this problem, I need to use the second derivative test to find local minimums and maximums. Second derivative test. Now, I still need to find where those local extrema are going to be by finding out where the first derivative is equal to 0. But the second derivative test is going to let me determine sometimes, in this case it will, whether I have a local minimum or a maximum without having to test the intervals of the first derivative. Let me just explain why that's the case for just a second. So I'm going to draw right here a local maximum. And you can see right here that my slope is very positive, getting less positive, getting less positive, turning 0, and actually going negative and more negative and more negative. So the rate of change of my slope here is negative. Even where it's positive, it's getting more and more negative. My concavity is negative throughout this entire interval here. And when that is the case, if my second derivative at the point of the maximum is negative, it means I have a local maximum. Conversely, if I drew a little as a local minimum, my slope is very negative, but it's getting less negative, and it's actually the whole way here it's turning positive. So if at this point right here, this local extrema, if the concavity is positive, that is, I'm going up like a cup, then this point right here is going to be a local minimum. So concavity positive at the local extrema, up like a cup, it's got to be positive. It's got to be a negative. It's got to be a local minimum. If the concavity is down like a frown, at that point right there, I've got to have a local maximum. So let's work it out algebraically. Let's find the first derivative. So my first derivative is 15x to the fourth minus, I don't know, what's that? That's 75x squared plus 60. And my second derivative is equal to 60x cubed minus 150x. So the first thing I need to do is find out, well, where am I going to have possible local minimums or maximums? And that is where my first derivative is equal to 0. So let's take the second derivative and scoot it down the page, and let's see if we can't find out where this might be equal to 0. So I'm going to do something. I'm going to factor out a 15, and that will give me x squared minus, x to the fourth. Whoa, come back. X to the fourth minus 5x squared plus 4. And I can factor that, and I want to find out where is that equal to 0. So I can factor that into 15 times x squared minus 4, x squared minus 5 equals 0. So that's 15 times x plus 2, x minus 2. This isn't a 5, it's a 1. Sorry, minus 1. X plus 1, x minus 1 equals 0. So I see I have possible maximums and minimums. I have critical points, which are also stationary points, at x equals negative 2, at x equals positive 2, at x equals negative 1, and x equals positive 1. So now I want to use the second derivative test to find out whether I have local minimums or maximums. So I'm going to factor this out into 6x times 10x squared minus 15, and of course that was, I could have done a little bit more. It's really going to be 30x, so I'm taking out another 5, 2x squared minus 3. Not 3, 5. I'm making all sorts of, no, minus 3. Sorry for all my mess ups here, it's minus 5. So it's really, if I had taken 30 out of this, I would get 2x squared, and if I take 30 out of that, I get minus 5. So I need to find out what is the second derivative at each of these points. I want to know if it's positive or negative, because where it's positive, I'm going to have a minimum, and where it's negative, I'm going to have a maximum, as we discussed in the very beginning. So let's start here and try it at -2. So if I have y double prime of -2, this term right here is going to be a negative. And, well, look at this term here is going to be, well, let's just do it, times 2 times -2 squared minus 5. This term here is going to be a positive. So at y double prime of -2, I am going to have a negative. A negative times a positive is equal to a negative. How about y double prime? So if it's a negative, this is going to be a local maximum. How about it? Y double prime of 2. Well, this is going to be a positive times, well, 2 times 4 is going to be 8 minus 5. This is going to be a positive. So this is going to be a positive. So this means this is going to be a local minimum. What about y double prime of -1? Well, this is going to be a negative, and this is going to also be a negative, because I have 1 times 2 minus 5. So this is going to be negative times a negative is a positive. So -1, I have a positive. That means I'm going to have another minimum. And what about y double prime of +1? This is going to be a positive. This is going to be a negative. It's going to be a negative. So I'm going to have a maximum there. So I've been asked to actually find the actual critical points here. So I know what the x values are. The x values are these right here. And I also have a pretty good idea which are going to be maximums or minimums. But let's see if we can find the actual points. So I have one point that's going to be -2 something, and one point that's going to be 2 something. You know what, I'm going to write these in kind of order here. -2 something, and then I'm going to have -1 something, and then I'm going to have 1 something, and I'm going to have 2 something. So what I did was I took my function, 3x to the 5th, 25x cubed, 60x plus 20, and I entered it into my calculator. So rather than doing all the math on these over and over and over again, I'm going to do the easy way, and I'm going to do, I put it into the calculator to my y1, I'm going to go alpha f4, I want to do y1, and I want to evaluate y1 for -2. And I press enter, and it tells me it's -2, 4. And I've already determined that that is a maximum. What about -1? Alpha f4, y1, I want to evaluate that for -1. I find out it is -18. negative 1, negative 18. And we already determined that negative 1 was going to be a min. What about 1? Alpha F4, Y1, evaluate it for 1. Well, it's positive 58. That's kind of a big number. And at 1, we determined it was a maximum. And at 2, alpha F4, Y1, evaluate it for positive 2, and I find out it is 36. And that, we determine, is a minimum. Well, let's graph the function. Zoom 6. Kind of crammed in there, hard to see. But what I'm going to do is this. I'm going to change my window. And I'm going to go from like negative 4 to positive 4. Because I know all my action is happening between negative 2 and positive 2. And then I'm going to make my y minimum. Well, hey, I know my minimum looks like negative 18 over here. So if it's negative 18, let's call it negative 25. And I know my maximum, I'm going to have a maximum at 58, a local maximum. Let's call it 60. Let's make my scale in terms of 5. And I'm going to go graph, and I should get the whole nice thing showing up right there. And indeed I do. And what I have here is I have a local maximum at negative 2, as promised. I have a local minimum at negative 1, as promised. I have a maximum at 1. What's happening? No, whatever. 1 there, okay. And then I have a minimum right here at 2. So everything checked out very nicely, and I checked it with my calculator. I could even check the values if I wanted to, but I'm okay with that. You can do that yourself.